Hi everybody, welcome to the LNROOM. I'm Tony Alden, and today in this episode 19 we're going to write a core lightning plugin in Rust, and the goal of that plugin is to register a method, my method, to a lightning D that return that JSON object. So when we call it with the parameters, the CLI parameters foo1 equal bar1 and foo2 equal bar2, we want those parameters to be in that response. When we start the plugin with the option foo_opt set to bar uppercase, we want the value of that option to be in the response. And the last thing that we're going to see how to do that is to get the node ID of the node running that plugin. So to do this, we are going to use the two libraries cln-plugin and cln-rpc, which are developed by Core Lightning developers in Core Lightning repository. And the goal of that video is not to learn exactly how the plugin system works, but much more to get started and be able to do things with those two libraries. But in case you want to learn more on how the CLN plugin mechanisms works, you can check LNROOM 14. So this is an example in Bash. And if you prefer another example that explains also the plugin mechanism, you can check Python this first slide that we did with build on L2. So let's go. First thing, we describe quickly the Core Lightning plugin system. When Lightning D start a plugin, it started as a subprocess and communicate with it this way. When it wants to send request to a JSON-RPC request to the plugin, it writes to the standard in stream of the plugin, and the plugin, when it has to respond to Lightning D, to communicate to Lightning D, it writes directly to its standard out. So this is done by Lightning D, those connection via pipes, and this is also we are not going to see this happening because this is done by a cln-plugin library, but it's I think it helps to know what's going on. When Lightning D starts the plugin, there is three phases. The first one, Lightning D send a get manifest request and Lightning D, and the plugin respond to that get manifest by telling Lightning D what are the startup options the plugin wants to be registered. Also, the register the JSON-RPC method, the notification, and also the hooks. So everything happened at that moment from the plugin to say, hey, I want you to notice those things. Then Lightning D send an init request, and at that moment, Lightning D gives us in that request all the information of the node running the plugin. So, for instance, we are going to be able to construct the socket path of the node running our plugin, and this way we'll be able to do some requests, and specifically the get info request, to get the node ID of the plugin. And finally, the plugin starts an IO loop and waits on its standard in the stream request from Lightning D. So this is for the system. So now let's look at our example. So we are in the terminal. Lightning is the Lightning repository. My plugin is a Rust skeleton of a plugin that we are going to see. So tree, and we can see tree of my plugin. So we have the file cargo toml with the dependency, and also the main in the source directory. Before we jump there and see how it works with the restarting point of a plugin writing with cln-plugin, let's source this file, which is in contrib startup. So with that those commands offered by that script in Lightning repository, we can start Lightning networks running on reg test with two Lightning nodes. So here, for instance, we're going to use only the this one, and we can see that this is an alias for Lightning CLI with the specific repository temporary L1-reg test, where are all the information of that node. So now we can change directory and go in my plugin, and maybe we can look at those dependencies, so the name of the package, but we are interested on those ones. So cln-plugin, so this is to write the plugin, and cln-rpc, this is to make a request, a get info request to Lightning D to get our node. Search JSON is to deal with JSON object, and we need the Tokyo library that is used to run the program asynchronously. So that's it for the dependencies. Let's do cargo build. Once this is the program build, we can look at source, main, and here is the a plugin that runs. It is the minimum to have a dynamic plugin. Thought it does nothing, but it runs. We are going to see a little bit after. So here at that line we use the module cln plugin with and we need the builder on error types. In Tokyo we need the standard in and standard out. We are going to see just after that macro how does it expand directly in the documentation of the library. But the important thing is that we have a main function, we have some state that we are going to pass to here to the start method, and we define at that line we start we build the first part of the plugin, specifying the standard in and standard out as we've seen before. We use the builder. We use the method dynamic to say that the plugin we can start it while the node is running. We start the plugin. We do that asynchronously, and we also report the error. And if everything is okay, that line, if I'm not wrong, if I understand correctly, the implementation of cln-plugin is to do a correct shutdown of the plugin when we stop the plugin. So this run, we're going to see how it to make it run just after looking at that macro. So we can read. So the hash bracket Tokyo main is a macro, and it transforms the async function main into a synchronous function main. So this is what we want. But that function initializes a runtime instance, and the async main function is run in that runtime. So specifically, so this is what we wrote, and the println we see a little bit that it is expand to that. So we have this defined a runtime, and in that block it run the body of the function asynchronously in that runtime. So I want this is all that just to make the magic of that macro goes a little bit away. So let's start our plugin. So it compiled correctly. And now we can start the plugin by running L1 CLI plugin start and okay, maybe I should have working directory and target debug, and this is a binary, my plugin. So we can start it. We see that it started, but as it does nothing, we can't play with the node and see things happening because nothing happens. We are in the IO loop where any request that could be sent to the plugin will result in nothing, but we still can check for the process. So we have the plugin running. Okay, fine. So this is the first part. We have the plugin running, but now maybe we want to define an RPC method, and that method will just return an object foobar. Let's see how we do that. So what we are going to need right now, we are going to need third JSON and the macro JSON, and also the type plugin. In the builder, before we start the plugin, we use RPC method. We give it my method, so the name of our method. Second argument is the description, so we just pass a description, and the last thing is we can call it the callback function, the function that when a client call my method and lightning passes the request to the plugin, we are going to constrict the payload which are going to go in the result field of the JSON-RPC response, and the function responsible to construct that payload is that one. So we are going to call it my method, and maybe we can call it func. So let's, and that callback function must be a nothing function, so maybe we can go there. So the name, this take a plugin, but as we are not going to use the plugin right now because we just returned foobar, we can write this. We have to pass it to put an underscore before the p. So plugin. So this takes a plugin. This also takes -v, which are the parameters, but as they are of type value third JSON value, we wrote them like that, and we return a result. Okay, result, and first this will be third JSON, okay, value, or an error. Okay, it seems to be correct. And here we do something. So as we do almost nothing right now, we want to return. So that macro JSON comes from a third JSON module, and this allows us to directly pass to use the JSON notation to write those answer, those result. So let's see if we have something working. So now we want to build. So let's see if it's built correctly. Now we start again the plugin, and now we can have the first. So this is my method, Okay, so we have written foobar, so we know how to define a method. So we use the method RPC method in the main function. So we go back in that main function. So this is here. We pass it an asynchronous function to do the payload, to constrict the payload, and this is what is written in the result field of the JSON-RPC response to the request my method. Okay, so let me brief a little bit. So we've done one part. Now, what we could do then would be to treat the case of the CLI parameters that are passed on the CLI when we call the method my method. So let's do that. So we no longer need this, and those parameters are in on the v argument, which is a set JSON value, and we can do something like that. And this will return. Okay, so this is a specific type, and in this type we can get those elements this way. So let's recompile. So we compile. Now we start the plugin again, and we are going to call my method with no parameters. Now with the parameter foo1 set to bar1, and we can add another one, foobar set to bar2. Okay, so now we know how to, let's go back to our note. We know how to define my method, JSON-RPC method. We know also how to get the parameter and how to return those parameters. Now let's treat the case of defining an option, a startup option, and see how we can have access to that startup option. So we put this one here. We are going to construct foo-opt, which is going to be that option. Okay, so we don't forget to put again the underscore before the v, because we are not going to use those parameters right now. So foo-opt, we can get those one, and we want also, now we are going to use the plugin. So when we define the plugin, when we receive the init method, as we've seen at the beginning, the second part of starting the plugin, we are going to set the config option, and the config option, so no, so it's p, and we want C. Yes, configuration. Now option. Sorry, I'm already in the next step. Now we have the option. When we pass the option in the init request, we have the option set, and we can use that method to get those. And as it is an option, we unwrap it, and as it is a specific options s value, there is that method to get it as a string. So in the case we find the way to define and declare the option foo-opt that we're going to a little bit in that part. This is how we get that option. So at the top now we need Okay, so we need the type config option and value from cln-plugin options. And we can add an option this way. So we need the option, we take the config option, we want a new one, and that new one takes parameters. It takes the first parameter, which is a string and is the name of the option. Then it takes a value as a string of, and so this is the default value that we want. So this is bar, but we have we want this as a string like this. And now the last part is the description. So this is how we add a new option foo opt with the default value being bar. And let's go back at the bottom, and this is how we get that option in the plugin. Now let's see if we did that correctly. So let's build it. So now we restart it the same way as we did before, so we don't set the foo opt option to something else. We want to see the default value, and now we can call maybe L1 and L1 CLI my method, and we have the default value, as we can see here, which is set to bar. Let's see how we can CLI plugin, how we can set that option and see if we did it correctly. So plugin stop, and we stop my plugin. Now we go to the node, and this is the command line we want to run. So with the dash key k we pass key value pair. Plugin subcommand, we start the plugin, so this is the same path as before, and not at the end, that we set foo opt to be bar. So at the top we run it, and now we should have it in the JSON response that we have here. So this is set to bar uppercase. So it seems that everything we've done so far is working correctly. And now we want go back to the node. The last thing we have to do is to see how can we get the node ID of the node running the plugin. So if we look at the Core Lightning plugin system, at when we receive the init request, we've seen already the option set by Core Lightning, and in the option method we find the way to get foo opt, and we are going to use something like that with the configuration to get this time the information needed to build the socket path. Once we have the socket path built, we are going to be able to use cln-rpc module to have a client that requests or not. I'm talking a lot. Let's write more code. So what do we want to do right now? So we just need to build a path. So we use that type path. We no longer want a foo option, but we keep it for after. This way we are not going to make stupid mistake. We want the socket path. So how do we get the socket path? And it seems that yes. So let's do something. So conf, because we want the configuration. How can we, and in the configuration, this is something that we have thanks to that method configuration, what do we write there? So nothings, because we get, yes, we just want the configuration. This gives us a configuration object types. So now we can build the socket path like this. Okay, path. We want a new path, and where do we have this? So we need to have a reference of the string that we get by conf, and we want lightning dir. We want to join this with the RPC file. So this is the file name, just the end of the path, which we have in RPC file. Let me check that. Okay, so we have the socket path that we get from the configuration. Let's get the path. We're using plugin, everything, path configuration value. Yes, okay, everything is okay. I wanted just to see if the compiler will complained, but it seems that no. So let's compile, and now okay, so we restart the plugin, and L1 CLI my method, and we should see the socket path. So with that socket path that corresponds to the node L1, we can communicate with Lightning D via the client that we're going to use right now with cln-rpc module, and we can do requests. So we are going to do the request get info to get the node ID. So let's go back to the main files. And we just need, okay, let's change that to the socket path. We changed it for node ID. We still need the path, we still need the configuration. Now we need the mutable client. So the client, we have it at the top. So this is the last thing that we have to uncomment. So we get cln-rpc, we have the model get info request cln-rpc, which we are going to use the new method of it, and the request and response type. Client, so we want a new client, and this is done with cln-rpc. We want a new, and we have to give it the path that we've built previously. We want to do this asynchronously and to propagate the error. So we do it something like that with the interrogation mark. Now, okay, so we are going to call it get info. We use the client. With that client, there is a method called call, and it takes request get info, and here we pass it so I think get info request, and this empty thing. So, and we do this with a wait. So now we should have a get info that have a specific type, and so to get the information, to get only the node ID, we need, maybe there is other way to do it, but the only way that I found is following. So node ID, we do a match, we match on the get info, and we are going to do something here, and in any other cases that are not the good one, we panic. So we want to match. So this is the type response, and response, I think that this is something like that. So response, get info. Okay, yes, get info, and this is here's the value that we want, which is get info of the type get info response. And if that match this type, we know that get info response is of type get info response, and so we can get the ID. Okay, let's see if this is okay. So we have the path we did before. We start a new client. We define a new client. We do the call of the get info request, and now we just want the ID part of that response, and we return it in our JSON response, which is a shared JSON value. Okay, cargo bull. Okay, so I forgot that semicolon. So we build it, and now blah 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 blah. Okay, we start the plugin, and if we do this, we have the node ID. Are we sure that this is the correct node ID? Let's find out. And we can do something like that. So jq-r and the filter.id, and this is the right node ID. So we are almost done with our plugin. We've done every part of the response separately, and now we can just build this together. So we are going to return JSON. We use that, and we can pass this one. So first, let's treat the foo option. So foo option, we don't want the bar upcase, we want that. So we can remove the last part. Now we remember that we can have access to those elements, to those fields using this way with self-JSON value. As we're using the V again, we need to remove the underscore. Also, we uncomment the foo option because we are using it. Let's remove that hard-coded node ID and get the node ID that we have constructed before. It seems to be okay for me. Is it for you? So we have that. Okay. So let's compile that program or plugin. Cool. Cool. But what we want is its runtime. So we started with the option foo offset to bar upcase, and we use the -k because this is what we have in the node, and we've said that we will be doing this, and we have our answer. Okay, so this is all needed to do to write the plugin. So this is the callback function asynchronous async that construct the object. We've used the information in the configuration to build the socket path and to use cln cln-rpc to build a client that connect to the node and do a get info to get the node ID. The last thing to say is that option that we get with the option method, and to define the plugin and start it. This is what it takes. So we use the builder, and with the builder we use the option method to pass the full opt option. We want the plugin to be dynamic. We register the RPC method and we start the plugin asynchronously with a wait. And at the top we have all the module and types that we need. So I hope you have a good time and you want to use cln-plugin and cln-rpc REST module. See you in the next video.